Hello, everyone. So this presentation is really about how to apply this fundamental principle of the internet, which is smart endpoint and a dumb network, to the modern days of multimedia communication and collaboration applications as smart end users and a dumb service. So in this presentation, I'm going to show how to unlock the innovation and flexibility of web audio video from walled gardens of cloud hosted software as a service apps to the endpoints which are controlled by the end users. So RTC Helper, which I'll talk about, is a software tool that can intercept WebRTC and related APIs and change the behavior of the web apps in real time. And this can be done on third-party web apps using a browser extension or by web developers in their existing apps. So first, I'll argue that uh, even though WebRTC or web real-time communication standard is open, the various browser implementation more or less are interoperable, the modern web apps that use WebRTC are often locked. So in this paper, there are several examples, several motivation use cases that I mentioned that the end user should be able to do, but they cannot do it because of the limitations of the existing apps or the vendor that has created the app. For example, you should be able to use your mobile phone as a webcam on your desktop video call as an example, or you should be able to send auto-transcribed captions while you are presenting and show some kind of webcam video as part of your screen share presentation. Another example is to allow an organization's IT to restrict the use of data channel which they might be scared of because it's completely opaque, or to help a web developer to quickly emulate failure or success conditions for testing and debugging without having to rebuild, redeploy after every change. Or for privacy reason, you could blur your face and body in a video call. This is showing on a Zoom video call from the web. Now, the tight coupling between the application that is used for communication and the service, the vendor service by each vendor, that tight coupling hinders innovation. That's the argument of this paper. For example, if you sign up for video conference from a vendor, you must also use that vendor's client application. Not only that, you must also use that vendor's note-taking, text chat, uh, meeting recording, calendar, and all other tools that is only provided by that vendor. So this is quite different than the traditional VoIP, voice over IP interoperability that was common a decade or so ago. Web apps for communication and collaborations, they tend to gravitate towards a closed ecosystem model. So the end result is that usually only the top few popular video conferencing apps, they dictate the complete user experience of a vast majority of end users. Also, once these vendors have enough users logged into the vendor's ecosystem, there is not much motivation to innovate beyond the following the feature set of the top product in that market. So this in turn gives an opportunity for us to do end user driven innovation, because vendor driven innovation often lags behind on many fronts. And this is specifically applicable for many WebRTC related features that are largely available in the client or the browser and not in the network or the service. So the goal of my project is to Allow the end users to customize their multimedia communication experience on third-party websites, web apps, and to also allow web developers to quickly create implementations of innovative ideas, emerging features on top of WebRTC. Now, the web developer can include this software as part of their web app source code. An end user can use a browser extension that is provided as part of RTC Helper software. So the project is available on GitHub. There is a video that helps you get started with the project. But let me briefly describe how this works. So if you are familiar with WebRTC, or if you're loosely familiar with WebRTC, this is how it behaves. You have two browsers, JavaScript running on these two browsers from the same application, and the browser provides certain APIs that are shown here, like get user media for getting the camera and microphone, or RTC peer connection for connecting these two browsers for exchanging the media path. This shows various APIs that are typically used in a two-party peer-to-peer media call. Typically, API intercept means is that you modify some of these APIs. So here it shows the get user media API being intercepted and modified, and inject the code based on your use cases, motivational examples, and so on. So instead of creating a generic intercept layer for all APIs, what I do is I divide the use cases and motivational examples into various categories, and then I define the intercept functions, intercept layer for those categories. Now these diagram here shows all the red marked as the different categories in the API layer. And the software allows you to not only intercept these APIs, these categories, but also inject a customized JavaScript function that can modify the behavior of these different APIs. Here, these customization categories are summarized in the paper, and they are detailed in the documentation that comes with the software. Now, each category can define a function signature to tell the user or developer that this is how it accepts the customization function. And the end user or developer can supply those customization functions that for any of these categories. So as an example, this shows the customization function that is done for recording. Whenever you click on the record, it launches this, and on the top you can see all the customization categories. Each of these category allows you to add a inject a function. We already supply more than 100 different pre-built customization functions as part of the software. They're pretty small, and all together are only about 3,000 lines of JavaScript code, but they cover a wide range of use cases in all these various categories that I described, that I showed. Most of these functions are very small, but only few of them cross 100 lines of code as an example. But the goal is for developers or end users not to just use these customization functions, but be able to modify them, edit them, and create their own for their own audio video communication experience on their website or third-party website. Now, the paper contains many other details that I won't cover in this presentation, but if you are interested, I would recommend read the paper and try out the software. For example, how do you install and use this? What are the different functions? How do they interact with each other? What are the motivational use cases? There are more than 20, 30 motivational use cases described in the paper. And how does this work differ from what others have been doing or has done in the past? I also cover some of the security implications and limitations of the software as well as this approach. So that's the gist of what unlocking WebRTC for end user innovation is all about. With RTC Helper, I demonstrate that many innovative ideas can be implemented and tried by the end user without depending on the vendor ecosystem for video conferencing and collaboration applications. So that concludes my presentation. Thank you.